everyone. In this video, we are going to determine the volume of a cone. An example of a cone includes the ice cream cone. We also have a traffic cone. So when we wanted to determine the volume of a cone, we're talking about how much can we put into the cones. For example, an ice cream cone. So we're asked how many centimeters cubed or cubic centimeters of ice cream can we put into the cone of a given cone. So that's an example of a volume. So volume refers to the amount that we can put into a particular of a solid. So in this example, we're talking about the cone. So the formula for the cone is, formula for the volume of a cone is 1/3 pi r squared h. Again, our pi is 3.1416. R represents the radius, and then the h, this time around, the h represents the height that comes from the vertex or the tip of the cone all the way to the center of the circular base. So again, there are two heights that we have here. The other one is this slant height. That's the wall. That's the height of the wall. But if we say the height that comes from the tip of the cone all the way to the center of the circular base, and then the radius right here starts from the center all the way to the side of the cone, the side of the circular base, and the radius and the height are perpendicular to each other, which means they form 90-degree angle. And this little square here is telling us that it's 90 degrees. Now, looking at this equation that we have here, the general formula for the volume of a cone is actually volume is equal to 1/3 area of the base times the height. So the area of the base that we have here is actually a circle. So remember, the area of a circle is pi r squared. So that's how we got this equation that we have here. Because others are going to ask, how did you get pi r squared? So the general formula for the volume is 1/3 area of the base. The base that we have is this circular base at the bottom of this cone. So that is a circle. To get the area of the base, since this is a circle, this is actually equal to pi r squared, which is the area of a circle. So this is the area of the base, pi r squared, and then the height, which comes again from the tip all the way to the center of the circle. At this time, I would encourage you to pause this video and try this problem out on your own. You solve for the volume, and if you're done, unpause it and check your answer. Okay, so we go over the problem here. So again, we got the formula in the first slide. I will put that formula up here because we're going to use that in determining the volume for this cone. So we start by writing V. By the way, in this problem that we have here, we are given 10 yards as the height. And then this 3 yards here is the radius. This picture is not drawn to scale. So the formula for volume again is 1/3, and then the pi value is irrational, but we rounded off to 3.1416, and then the radius that we have is 3 yards. So that's 3 yards, but we have to square it, and then we have the height here in this problem is 10 yards. So we're gonna multiply. Before we do that, we're gonna square the 3 yards first. So that would be 1/3 times 3.1416. 3 times 3 is 9. Yard times yard is yard squared. And then we have 10 yards. And so we multiply them all together. And that's 1/3 times. So multiplying these three, this would come out 282.744 yards cubed or cubic yards. You can say cubic yard on this or yard cube. They're just pretty much the same thing. So in order to get 1/3 of this value that we have here, all we need to do is to type this into the calculator. 282.744 divided by 3. That's one way to find the 1/3. So the answer here is 94.25. I rounded it off. Cubic yard or yard cubed. So this is the volume of this cone. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example here. So this time around, we do it backwards. I give you the volume. So you have a volume, and then we are given the height, and we are supposed to find the radius. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's move on to this problem here. So we're doing it backwards again. This is our height, and then the radius is missing, so we keep that as x. So we plug values in, so our volume is 41.888 centimeters cubed is equal to 1/3. Our pi is 3.1416. The radius that we have here is r. We keep it as r squared, that's missing. And then the h, or the height, is 10 centimeters. And then from here, we are supposed to get rid of the 1/3. We can do that by multiplying both sides by 3. So if we multiply 3 to both sides, we can get rid of the fraction 1/3 here. Okay, so we multiply these 3 times 41.888 centimeters cubed. This would come out 125.664 centimeters cubed is equal to, now multiplying these two together, this would come out 31.416 centimeters. And then we also have r squared, so times r squared. It's the r that we're looking for. Now, in this problem that we have here, we're supposed to solve for r, so we're dividing both sides by 31.416 centimeters. Divide this by 31.416 centimeters. It should be noted that this centimeters cubed means there are 3 centimeters in there. So we're taking one of the centimeters, so we're left with 2, and we take the centimeters at the bottom, we cross it out. So then this 2 gets crossed out, so we're left with r squared on the right side of the equation. And then if we divide these two together, that would be 4 centimeters squared. Now we want the r, so what are we going to do is we square root both sides. So once we square root, the square and square root is going to get crossed out, so we're left with r. And then square root of 4 is 2 centimeters squared. You cross out the squared and the square root, that would come out to be centimeters. So the radius of this cone that we have here is 2 centimeters. This is not drawn to scale. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!